All right. Looks like we are pretty much all here now. So we're going to get started. Welcome to our commonly misunderstood standards webinar. We did one yesterday for math grades K to 5, and today we're focusing on math grades 6 through 8. First and foremost, we want to thank the New Hampshire Department of Education. It is thanks to them that we're able to provide these webinars to you for free. And so we thank you for coming and we thank them for being able to deliver this to you. So my name is Marissa and I work for Demonstrated Success and I am a school support and math specialist there. And I'm here today with my colleague Heather Jenkins.
Hi, everybody.
And we also have Gray Harrington here with us today from the New Hampshire Department of Education. And we have Kristen Crawford listed here as well. She is the lead on this contract that we have. So we have her here. She comes to some of the webinars, but her information is linked at the end if you have any questions for her. So here's our targets for today. So you know what you're sort of going to leave the webinar with by the end is that we want you to have a good understanding of the progression of the key Common Core standards that's across the grade levels. We're going to talk about how they evolve both in meaning and complexity. And we are going to talk about them in a K to 8 model because that vertical progression is important that we all have an understanding of. We're going to identify commonly misunderstood math standards for grades 6, 7, and 8. We're going to give you some examples and some strategies. And then we're going to then explore further strategies on how we can uncover and address other misunderstood standards that you might come across for more than just today. So we're going to shut our cameras off just so you're able to have full access of the screen, and then I'm going to kick it off to my colleague, Heather.
All right. Thanks very much for everybody again for coming. I am going to do just a little bit of an overview of standards. Anytime we talk about some misunderstandings that we have, I just want to make sure we're all on the same page when it comes to our standards and what we're looking at. So when it comes to math, Marissa and I are on site a lot and we talk to folks about math, and there tends to be this sort of blame game for the younger grades. Like they must not have taught what they needed to teach because now they're coming to us and they don't have those particular skills. I think all of us have kind of felt in the middle of that, whether it be the next grade level up is telling us that we weren't necessarily focusing on what we should be focusing on, or they're not getting it. And then we're thinking, what in the world were they doing before our particular grade level as well? What we just want to remind everybody is we're all doing our best. We're all trying to do what we can to ensure that we're teaching to our grade level standards. And we have this little bridge here saying that we want to basically just bridge from one grade level to the next and not sort of, you know, make assumptions on what was taught or not taught. We're just going to do our best to be able to understand what we need to teach at our grade level and do it to the best of our abilities. When it comes to the standards, we're always talking about, when it comes to math, the Common Core state standards for New Hampshire. They are the technically New Hampshire state standards, but they are all the Common Core standards for math. When it comes to the K to 8 standards, they were sort of redesigned. It's been kind of years now, but they are internationally benchmarked. The biggest sort of, shift or thought process around it was making sure that they are not only providing guidance for what you would have at each grade level, but also the amount of rigor that's needed to build that conceptual understanding, along with some of those procedural skills and fluency, and also the application of those particular skills. There are key concepts that are focused on at each grade level. We're going to give you a couple of little examples of where you can find some of these key concepts. Obviously, they're in the standards, but sometimes we need a little bit of help figuring out what are the big ones for my particular grade level. We also have progressions. They're a developmental progression, and basically getting students to that all the way through 12th grade to that college and career readiness. So when these were created, they were doing it in a coherent way that would link topics so that as they move through the grade levels, they will get whatever sort of base understanding they need to be able to do things in the next grade levels and all the way up through high school. In doing this, a lot of the standards, and for the most part, what happens is we have a key concept, and those concepts have like a 3-year cycle that they move through. So maybe in one grade level, it is something that is introduced as a topic. So it might not be a major standard for that grade level, it's more of an introductory. Then at the next grade level, they're doing a lot of work on that. So it might be a little bit more of a major standard in that grade level. And then the next year, it might end up being a little bit more of a, again, not a major standard, but they're securing it and just basically making sure the understanding is there in that next one. Most of the concepts in math run in that sort of 3-year period. So as we talk about that, we want to make sure that we understand what comes before and what comes after. Sometimes when we focus just on our grade level, we start to hyper focus on that and not be able to kind of keep sort of the end game in sight and where it's going next. So there are times where we might spend more time on a particular topic than we need or less time than we need. So we want to be able to see the whole picture. Specifically with math, it's very important for you to understand what comes beforehand so that you can know if students aren't getting something specifically at your grade level, well, what were they learning before then that would actually help them to be able to apply what they learned before to meet the needs in your grade level? So this here is the key concepts at each grade level. We did want to make sure that we had in here all the way from kindergarten up through 8th grade. I know we're focusing on grades 6 through 8 today, but when we look at all those concepts, we're starting in the lower grades with that addition and subtraction. In 3 through 5, we're looking at multiplication and division and fractions. And then in 6th grade, we're looking at that in relation to ratios and proportional relationships and early algebraic expressions and equations. So again, building on those concepts in the lower grades. In grade 7, you're looking at the same ratios and proportional relationships still, and we're looking at arithmetic of rational numbers. In 8th grade, you're taking all of that, and now you're looking at linear algebra and linear functions. So these are some of those shifts that were made years ago when we were looking at the Common Core, and what they were hoping to do is focus on fewer topics in each grade level so that they would be getting those and being secure in those particular skills before they're moving on. Talking about those key concepts, there are sort of 3, I guess, buckets that we're looking at for understanding and for students to be able to really look at in when we're instructing. And one of those, and I feel like is the most important one that we need to focus on, is that conceptual understanding. They need to be able to be flexible with numbers. They need to understand numbers. They need to be able to apply what they had understood in other ways and not just say, here's the procedure that I need to do, and this is why this works. They need to be able to understand that procedure so that they can take that and apply it to more complex problems. So that conceptual understanding is key. Then we don't want to forget that procedural skills and fluency. This does not mean skill and drill. But what this means is as we are building that conceptual understanding, we are all then strengthening those procedural skills and the fluency that they have with that. So they do need some practice with some of those fluency skills and those concepts. And I think I said it yesterday, and I'll say it again today. It's kind of like reading. We can give students all those skills to be able to have reading, but if they don't have fluency, it makes it really difficult to be able to move on to that sort of comprehension side of things. So we do want them to have that procedural fluency, but not at the expense of conceptual understanding. The last bit is that application. So we want them to be able to say, okay, I understand this concept and I can take what I'm understanding in my classroom and apply it to either an assessment that they're taking that isn't necessarily part of a program or to a novel situation. We want them to be able to take that and apply what they're knowing to new situations and new types of problems. When we're looking at the math standards, we have different domains of math. Obviously, we're looking at that. We also call them reporting categories because sometimes if you're looking at New Hampshire SAS, they're combined into one. But your domains of math are obviously telling you which areas of mathematics that you're going to be teaching. So here's the example of the number system and ratios and proportions. Those are different domains of math. Underneath that, we have our different clusters that are within a specific domain. So as we're looking at the real number system here, we can see that we have two clusters that are extend the properties of exponents to rational exponents, and then use properties of rational and irrational numbers. Within that, you have standards that are listed underneath there. Sometimes there's one standard, sometimes there's two, sometimes there's three, just like on this particular example that we have here. And the way that they created these particular standards, moving into these, clusters, is that these are all of the things that take a specific amount of cognitive rigor to be able to meet that particular cluster. So sometimes it's one really rigorous standard, and other times it's more than one, like two or three sort of um, less complex standards that they need to all put together to be able to meet the understanding of that particular cluster. We wanted to show you here and make sure you understand this domain progression. This is really important for you as you teach middle school and knowing what particular standards and what domains feed into what you are teaching. It's also helpful for you to know in grade 6 through 8 where your instruction is going in high school. So I've always really liked this progression to really give folks a picture of sort of which domains feed into other domains as we move up through the grade levels. These are the New Hampshire Department of Education model competencies. This is an example of numbers and operations base 10. I know that's not necessarily what we're looking at in grades 6 through 8, but if we look at the model competencies for the, you have it, mathematics 6 through 8, you got it, or the K to 12, it doesn't matter, whichever one.
I'm sorry, it's on my other screen.
Okay, that's fine. Basically what you're going to have, if you go back to the standards here, on each particular there's particular tabs that have to do with every single domain of math. This one just happens to be numbers and operations base 10. And what that does is it brings you through all the way from kindergarten up through the end. We just showed through second grade because we had to do a screenshot. But what it does is it tells you what the progression of those skills are. I want to give a shout out to Annie Wallace. She was the one who was an integral sort of person to be able to get these done for the state. But as you go through, you'll be able to see the domains that you have for like expressions and equations, and it will go through all those particular standards and clusters and skills that feed in from one grade level to the next. So they can be really helpful for you to be able to look at where your grade level fits in to what came before and what's coming after. Another good resource for understanding our standards and making sure that we're dialed into what we need to spend more time on and what we might be able to let go if students don't have mastery of. Achieve the Core is a site. We have it linked here. You don't need to go into it, Marissa, but each grade level has one of these documents. And what this does, this is grade 7 right here, is it highlights on an algebra progression. So this is getting us to that, as of 8th grade and into 9th grade, we want students to be able to make sure that they are able to move into algebra in high school and get ready for that college and career readiness. On the algebra progression, these are your major standards, which are the green ones, your supporting clusters of standards, and then your additional clusters. So green are the major, blue supporting, yellow are additional. Again, it's not that all of the standards aren't important, but again, if you're needing to take more time and slow down and make sure kids have it, make sure you're looking at the green clusters and spending some extra time on that as opposed to taking 3 months to do one of the geometry particular clusters of standards if you are teaching 7th grade. On the backside of all of these, it shows the progression from kindergarten through 8th grade and those major skills that are moving them towards algebra in high school. Achieve the Core, again, I just want to just point out, it is the algebra progression. There are other progressions that are geometry progressions and things like that. Right now, at the forefront is algebra. I know coming up and down the pike is going to be data, statistics, and probability, just because that's what's needed in the workforce. And so I'm sure at some point these will start to change a little bit over time for the importance of them. But right now, this is what we have, and it can be a really great starting point for you. When we talk about standards, some of the forgotten standards are those standards for mathematical practice. These are universal, regardless of your grade level. These are K to 12. And if you have specific programs, sometimes some are better than others at saying, here is your major grade level standard that we're looking at in this particular lesson today. And here also is your standard of mathematical practice. But for the most part, we tend not to see folks really focusing on these mathematical practices. And they're huge. They are the ones that are going to have students be able to persevere in problem solving. Those kids that got it really easily when they were younger and don't necessarily have it as easily as they get older have an absolute like crazy hard time with that perseverance and being able to solve things. So we want to make sure that we're always highlighting that. The other ones are being able to um, look at things and explain your thinking, use models to show your understanding, and make sure that we're able to use appropriate tools and not just traditional algorithms and so on and so forth. So these are super important.
I don't see any questions. So again, if you have any, please drop them in either the chat or Q&A, and we will continue on to now the misunderstood standards that we've sort of identified for this webinar today. We wanted to start off with, specifically in middle school in grades 6 through 8, is that and you'll see this sort of theme throughout. This was a theme in the K to 5 one as well. It's also sort of a theme in the 6 to 8, is that a lot of the misconceptions or misinterpretations of the standards are around procedures and jumping to procedures before we start to or before we begin with a more conceptual understanding with students. So they might not be procedurally difficult, but the standards require deeper reasoning from students. And that starts in the younger grades, right? So we need to make sure that we're continuing that conceptual understanding and manipulatives and modeling. That does not go away in middle school. That needs to continue in middle school. So that's sort of, what is the theme of the misunderstood standards that we're going to be going through today. So we first want to talk about some general misconceptions related to the K to 8 math standards in general. And we can't do that without talking about the standard algorithm for a number of reasons. Um, we work, as Heather stated, with schools and teachers, mostly in the area of math. And like we'll talk with grade 6 teachers saying that students are coming in and they don't know how to do long division. And so what's important is that for those sixth grade teachers is that long division using the standard algorithm is not even in the standards until grade 6. Like it's okay that students are coming in and not knowing the standard algorithm. So this here is just a layout of when the standard algorithm is actually introduced into the grade levels. So starting with grade 4 is addition and subtraction using the standard algorithm. Grade 5 is multiplication, and grade 6 is division. And I'm sure you see it in middle school all the time as students come in and they don't have that number sense, right? And so that is a direct result of the standard algorithm being introduced too early. Students are not given enough time to to use numbers, break them apart, compose, decompose. And I think it's important as well is at the middle school level, especially if you do any sort of intervention time where you are revisiting prior grade level standards, is that you sort of start back to the beginning and really working with students in those areas. And as you may have seen, is that word fluent, right? And there's that they'll be fluent with the standard algorithm. And so if anyone hasn't read this article here, Fluency Without Fear by Joe Bowler, it is an amazing read. And what we're sort of highlighting here is that the Common Core, right? Even though it has that word fluency in there, it actually de-emphasizes the rote memorization of math facts, right? We hear it all the time. Students don't know their math facts, they don't know their math facts. Um, so I'll keep going. Well, we're going to revisit this. But it's really that misinterpretation of the meaning of the word fluency in the Common Core, which you might see in any resources you might choose. It might be in a program that you might use, is that it's encouraging that rote memorization. And that's not how we're going to get students to know and understand their math facts, right? We need it in middle school because of those. We need them to be more efficient because we're learning those deeper concepts. So those concepts that they were learning in K to 5, we need them to be a little more efficient with. However, if they're not, the answer is not continuing to have them memorize their math facts. So that procedural skills and fluency that Heather had outlined earlier, right? The standards, they're calling for speed, they're calling for accuracy in calculations. So we don't want to send the mixed message, right? That students should not be able to do it with speed and accuracy and be efficient. It's just how we get there. How are we going to accomplish this with students? Because what we're doing, right, is not working. So when we address fluency, we need to do that through supporting materials. And so we do that, we build that procedural fluency that starts with conceptual understanding. And that goes, we started off with sort of, the standard algorithm and math facts, but that comes from anything that you're teaching your students, anything that requires, accuracy with a procedure and fluency, you have to start with the conceptual understanding first for students. So this is a graphic from NCTM, which we really like because it's talking about conceptual understanding and that we need to make sure that we're teaching students the concepts behind the procedures first before we're actually instruction and doing instruction or teaching them tips and tricks on how to get to an answer more quickly. And we do have to say this because sometimes it sort of seems like, well, Marissa, we understand that. But you live it every day. We go and we visit and we work with teachers, and that's not always being done. So we want to make sure that we name that. I like this one as well, where students often have difficulty with conceptual understanding. That is very much true. It is difficult for students to build that conceptual understanding. And so sometimes we want to go for a quick sort of win with students. We want them to feel confident and we want them to have some success in mathematics. So we sort of jump to any procedure that involves steps. And that can sometimes give them that confidence. And what we don't always realize is that's a sort of short-term fix, right? It's helping them maybe in the moment, but it has long-term consequences for their ability to make connections in math and go deeper into the math that they're learning. So when we think about the word fluency, we want to make sure that we're thinking about it in terms of knowing how a number can be composed and decomposed. We can use that information flexibly and we can be efficient with solving problems. So this is the goal. And I think that even though, you know, this might not seem something that's appropriate for 6 through 8, is that it is something that we see in the middle schools a lot, is still trying to continue to build number sense, and fluency and flexibility with numbers. And just some food for thought, thinking about ELA. Some of you might teach ELA, some of you may not, depending how your school is sort of set up. But when we think about ELA and, introducing even vocabulary words, teachers aren't giving students a ton of vocabulary words to memorize and be timed on them. They learn vocabulary through speaking and listening, reading and writing, and they're using that vocabulary, and that's how they're building that fluency. And we need to sort of think of that as well, and that's how we treat mathematics. We also have the 13 rules that expire. Some of them are related to middle school standards. Not sure if you've seen this before. We've linked it here, but for instance, the please excuse my dear Aunt Sally in 6th grade, and even 7th grade, that is a rule that expires. Improper fractions needing to always be written as mixed numbers, the keywords to solve problems. So these are some examples here. Two negatives make a positive. Some are, more K-5 related, but some are also 6 to 8. And then we also found some for middle school misconceptions. Starting in 6th grade with the variables, is that thinking and having students think that a variable is a single value and not a range of values. So for those of you who teach 6th grade math and you're sort of, you know, it's unknown numbers introduced previously, but in 6th grade, when we start to talk about the variables, making sure that students are understanding that, X isn't always a single value, that it can be a range of values. And same thing with the equal sign, thinking that means to put an answer here. We know that as we continue through the grade levels, that's not what an equal sign always indicates to do. So just some general misunderstood standards. We're now going to go through 2 examples for grades 6, 7, and 8. So we're going to start off with grade 6. Just so you know, at the bottom of each slide, there is a link to the source. The source has a lot more information than we could put on these slides today. And so we sort of just captured a few thoughts. You'll get the slide deck, so you'll be able to look through these sources and sort of think a little bit more. They have tasks that you can use and more instructional strategies. So we encourage you to go through them. So what we first wanted to highlight is These are the domains with major standards in grade six, the ratios and proportional relationships and the number system. And out of those two domains, these four standards are the most commonly misunderstood standards for teachers when they're delivering instruction. I want to sort of highlight that. Like when we're talking about misunderstood standards, it's really that teacher perspective in our instruction is how these articles and Achieve the Core has framed the specific ones that we've chosen. So this is the first one that we've sort of highlighted is finding the area of right triangles, other triangles, and special quadrilaterals. And making sure that we're doing that by composing into rectangles or decomposing into triangles and other shapes. Where the misconception is, and when educators might be delivering instruction, is that it's not always focused on finding the area by composing and decomposing into rectangles and triangles. A lot of the times we look at that and we might think that instruction focuses on the formula for the area of a trapezoid. And so what we or achieve the core, right, is telling us is that we do not need to know how to find the area or memorize the area of a trapezoid. Let me say the word memorize. I'm going to start there. We don't want to have students require the memorization to find the area of a trapezoid in this particular standard. So the intent of it is to have students compose and decompose figures in order to find their area. This is a task that's linked that delivers the true intention of this standard. The next one that we have is the number system. It's to interpret and compute quotients of fractions. And where, I'm sure you know where I'm going with this, keep, change, flip, that instruction focuses on this algorithm and not students not having the understanding of why we even multiply by a reciprocal and why that even works, right? Why do we keep, change, flip? Why can we even do that? And we're not including visual models. So here we are showing an example of interpreting, sorry, division of fractions. And so these are some of the models that that standard is looking for. So here is an example of a visual model for 2/3 divided by 3/4. And here's another example of a visual model for 2/3 divided by 3/4. There is a question. It's something to do with yogurt, which you can click into the source and read more about. But when we're asking students, right, we're not asking them to, keep the first fraction the same, then multiply by the reciprocal of the second fraction. We're having them draw models about their thinking. And I know that can be difficult, right? Like we want students to be able to use models to show their thinking. And sometimes when we are talking to students about drawing models, um, it can feel like a lot, right? Like students are struggling to draw models. So that's why sometimes we sort of just jump to that procedure, but we need to make sure students are understanding, why they're doing what they're doing. For grade seven, these are the three domains, ratios and proportional relationships, the number system, and expressions and equations. These are the five most commonly misunderstood standards in grade seven. The first one we're going to look into is applying and extending previous understandings of addition and subtraction to add and subtract rational numbers. Um, where the misconception is here is that instruction focuses most of the time on the integer operations rather than the full range of rational numbers. So it's really focusing on those integers. You can look into some of the sources. That's even what is being asked of students in the different sort of resources that you might use. Um, we want to make sure that we are having students, focus on the full range of rational numbers. The second part of that standard is to represent that addition and subtraction on a horizontal or vertical number line diagram. This is very important for students. We've been in classrooms where, they have their assessment on this standard and they have their rules right next to them. How you add integers or rational numbers, how you subtract into mainly integers, but the rules for that, right? And so we need to throw those rules out the window. We need to have students show their understanding on a number line. And so these are just some instructional strategies for you that you can take or read more about when if you're a seventh grade teacher teaching this standard, and how we can get students to show their thinking using number lines. The second one that was identified for grade 7 is to decide whether two quantities are in a proportional relationship. This is a longer misconception, and that's mostly that instruction will be isolated to using cross products as a strategy to test for equivalent ratios. And so this shows you here a progression of this standard of the table to the graph. And so we want to make sure that, we are taking students through that progression. Again, you can click into this link here to read a little more about it. But also a good amount of that instructional time is used to having students fill out a table of values. So what you're going to see here in one of the ways to sort of, address the true intent of this standard is that we want to give students a table with the tables already completed for them. And so this is an example of a frozen yogurt example. Um, and so we want to make sure that this example is that we are working on proportional relationships by analyzing the tables and graphs, and we're not using cross products. This is an Engage New York example. And it sort of talks you through and walks you through how you're going to get students not to use cross products in order to determine if the ratios are proportional. And then lastly, we have grade 8. These are the three domains with the major standards. So for expressions and equations, functions, and geometry, these are the most commonly misunderstood standards for this grade level. And the first one we're going to reference is the Pythagorean theorem and applying that to determine unknown side lengths and right triangles. So what we see here, or what instruction is mostly focused on, is that we're applying the Pythagorean theorem to problems that are only two-dimensional without any context there. So what we have here for an instructional strategy is that this is a grade 8 task from Open Up Resources, and it is ensuring that we're pushing students for that three-dimensional application, right? So they need to use Pythagorean theorem twice here in this context, once for finding the length of the hypotenuse, and the second one is using a two-dimensional drawing of a three-dimensional figure. That can be difficult for students to visualize. So again, manipulatives, physical models of those prisms will be very helpful for students. Again, even though we are getting up into the grade levels, those manipulatives and models should not be going away. They should continue to be, available for students for all, all sort of standards that you're having your students learn. And then the last 8th grade misconception here is to use similar triangles to explain, I apologize, that's supposed to say grade 8. I'm using similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. So where our misconception is here is that instruction is limited to using the formula to calculate slope rather than developing the conceptual understanding that is required by the standard. So how we can approach this instructional strategy is that we need to approach it more conceptually and make sure that we are not teaching any procedures for students. What we want to focus on is help students understand the meaning of the word slope, right? What it means in context, what its connections are to ratios and proportional reasoning in grade 7 and in transformations in grade 8, rather than just beginning with the slope formula. So this is an open up resources lesson. And what it has students do is explore why two triangles are similar and have them discover that any right triangle drawn along the same line has a constant ratio of vertical to horizontal change. So again, this is a great source you can go into and read more about how to get students to understand more conceptually first, rather than teaching them the slope formula. I don't think I see any questions. So again, that was a lot of information. It's really hard to quickly go through it in a webinar like this. That's why we linked all those sources for you. Um, please go through them. They're quick, but they can give you more strategies and context around the best instructional strategies for these particular standards that are usually introduced with a procedure and it's not starting off conceptually. Before we start this next section, I just saw a question about where we're getting their slides. Um, the slides will be sent to your email tomorrow, about 24 hours after this ends. So the documents that Heather showed you in the first section for Achieve the Core, that's where most of these that's where mainly all of the commonly misunderstood standards information is coming from. And so within Achieve the Core, they have different examples or different examples of assessments, different resources. So some of the ones we chose today were open up, but there are more resources linked to these slides than or in the Achieve the Core than that was linked here.
And then the next question is, just to answer really quickly, is yes, you will still get the slides even if you join late. Everybody who registered for this particular webinar will get the slides tomorrow afternoon when the email goes out. Okay, so this next section, Marissa went through what the common misconceptions are in grades 6, 7, and 8. But what I want to go through in this next section is, okay, so now we've got the common ones, but what are the other standards at my grade level, and how can I make sure that I don't have misconceptions about some of the other standards? We always know that, the standards are what the standards are. We have our interpretations, and sometimes the misunderstandings, whether we want to believe it or not, they begin with us. So we want to make sure that we are really honing in on and figuring out where those understandings are lying. So here's some information for you. To be able to look and deepen our understanding of standards, obviously we all have our grade level standards. Most of you, especially at the middle school level, teach a specific grade level depending on the size of your school. And so you're pretty well versed in your grade level standards. But again, we want to make sure that we're understanding not just what the standard is saying for identifying those components, but understanding the level of mastery also that needs to be looked at for that particular standard. So we're going to talk about breaking down and being able to unpack a standard so that we can figure out what are all the skills associated and knowledge associated with a particular standard. So the first thing we're going to do is we're going to take a look and isolate keywords in the standards, figure out what the contents are, what is going to be a process for mastery for that. Then we're going to look at links between that particular standard and that cluster that it falls underneath, right? Sometimes we get so granular into a standard, we're not thinking about that cluster that is actually where this standard is sort of coming into play with overall understanding for a student for a particular sort of concept. And then we're going to turn those into an I can statement or a student success criteria or what have you. So this next slide here is the link to the template that we have for unpacking standards. So the first things first, you're going to pick a standard that you want to unpack, and then you're going to look at all those verbs, nouns, and adjectives. You're going to move on to those skills, knowledge, and understanding, and then what students will be able to do, um, how students will know what they need to know how to do, and then what students need to understand how to do. So let's keep, if we go here, I know this is a fourth grade standard, but it works the same for everything. So the first thing is you want to pick out those words that are like those key sort of phrases and understandings for your students. So we've got our verbs here. We've got like the multiply, illustrate, use, explain, and then those nouns and adjectives that we have. So we're looking at whole numbers, we're looking at place value, properties of operations, arrays, all of that. And then those verbs, we can start to look at what are the skills that are needed to be able to do those things. And then once they have those skills, we look at what students are able to do. So yes, we have these skills, but what do we actually want them to be able to do with those? That's the sort of progression of the verbs and the skills and what we want students to be able to do. Then we have our nouns and adjectives. So what we want our students to be able to know, what knowledge do they need to have? And then what are the understandings that they need to be able to have to be able to understand some of these particular concepts. So the knowledge moves into students will know and what they're going to be able to show knowledge of and what students will be able to understand. And so all of this starts to bring you down to the nitty-gritty of exactly what do we need our students to be able um, to um, to do, to know, and to understand, to be able to meet the needs of this particular standard. We did an unpacking standards webinar already. We just wanted to link it here because it's got some good slides in there. It has both ELA and math, and it's got some interesting additional information about how you can unpack a standard. But we didn't want to spend too much of the time here. We just wanted to talk mostly about misconceptions. But the link is here for you to have and to look at a later time. Another resource that we have here is when we're unpacking standards, it's really useful to be able to look at depth of knowledge, right? So when we talk about the rigor or when we talk about how deep we need to go with a particular standard, the PLDs, these are New Hampshire SAS. They're called performance level descriptors. And what they do is every single standard, this is grade 7 here. Marissa, would you mind taking the summary off real quick? Just because I think it makes it, oh, it doesn't make it bigger. Basically what it does is it takes each particular standard and then it will tell you if you had a student what they were doing that was a level 1 student, this is what they would be doing as a level 1 student. So like on the New Hampshire SAS. So you can see it's not really exactly like depth of knowledge 1, depth of knowledge 2, 3, and 4, but it tells you what a student who is below proficient would be doing, what a student who is approaching proficient or a level 2 would be doing. It tells you what a proficient student or level 3 is doing and what a highly proficient student will be able to do when it comes to that standard. These have been game changers for teachers when we go on site to be able to look at this and say, okay, as I unpack this standard, or I think that I truly understand this standard. When teachers go in here, they will sometimes look at this and say, oh my gosh, I do understand the standard, but I am actually teaching to a level 1 student, like below. I am not teaching to the depth that I need to with this particular standard. So these can be really helpful in understanding. You would want to be really teaching to the level 3 or level 4, um, minimum level 3 student, and what they would be able to do and show for this particular standard. So these can be super helpful. Okay. The next thing is when we're looking at addressing misconceptions and looking at it with depth of knowledge, this is an example of a sixth grade standard. If we read the sixth grade standard, we can see they need to find area of different shapes, right? We need to make sure that they're, decomposing, rectangles and into triangles and all of that, and just applying these techniques. So if we're looking at this with a depth of knowledge 1 or 2, all that students are really doing is they're relying on formulas to be able to figure out and to, you know, I'm losing my word right here, basically to know what the area of a particular shape is, right? So it's a computation thing. The true intent of this standard, which is more like a DOK3, is to make sure that students can use what they know and look at not just the formulas that they have here, but to be able to say, all right, how can I figure out and decompose something, maybe to figure out what an area of something that might be unfamiliar, right? They might be able to rearrange shapes. They might be able to use, reason using their models or different types of equations. So that task example would be they're trying to find the area of a trapezoid. So now they're looking at, okay, the trapezoid is drawing a rectangle and a triangle. So they're able to find the area by decomposing it into smaller parts, using what they know, finding those particular areas, and then be able to develop a general understanding, and a general formula for finding the area of any trapezoid, not just the one that they're looking at. As we look at this and we think of depth of knowledge, we start to sort of reframe our thinking and our understanding of standards. Whenever we have misconceptions about those standards, we need to make sure that we also then look at our assessments, right? We can't continue to assess the way we were if we were misunderstanding the assessments, and the assessments weren't necessarily getting to what we were hoping they were getting to. So you just want to make sure you review your assessments. You want to make sure they directly reflect the intent of any sort of rigor or the depth of knowledge for any particular standard. This backwards design is super helpful as well. I talked about it yesterday. A lot of programs out there are great. You can turn the page and it will tell you what standard you're going to be working on. It does a really good job of, teaching in that particular day, in that moment. But without this backwards design, and you as a teacher saying, okay, let me think about this unit as a whole. Where do I want students at the end? How am I going to get them to the end? Not just teach in isolation for today. You want to be able to do, even if you have a program, that backwards design and say, hey, kids, this is what we're doing today. The reason that we're learning this today is, again, at the end, this is what we want us to be able to do. This is going to help us get there. Let's dig in. So you want to do that backwards design. And then again, we just want to make sure that there's no misalignments, and any sort of gaps in your instruction for what you need to be ensuring that your students are securing for your particular grade level. When it comes to those assessments, we talk all the time about formative assessments. Those formative assessments are the best way for us as teachers to know sort of where are my students at? Where do I need to go? What am I going to do next? It also helps students understand how close they are to mastery of a particular skill, or to be able to say, wait, I have a misunderstanding about this. I'm not really sure how this works. And you can work with your students to be able to figure out where their misconceptions start and how you can figure out what to do next to be able to have them grow their thinking and to make sure that they're getting those concepts that you need them to truly understand. When designing formative assessments or any sort of prompts, the first thing you want to do is make sure that whatever you're asking them is actually going to reveal what they think. Okay, not just what they remember, those procedures. We don't want them to just be procedural. We want to always encourage explanations or demonstrations. The big thing for this, it starts in the early grades, but it continues very much through middle school, is we accept the I just know. Can you explain your thinking? I just know. And we say, oh, okay, we'll move on. Yeah, maybe you do know. But those are the students in the early grades that say they just know that really crash and burn in the upper grades because they don't have flexibility in thinking. They know a procedure, they can easily do that, and they just move on from that. And there's a small percentage of students that will do just fine all throughout their math careers with doing that. But for the most part, those are the students who say, I don't understand math. I don't like math. They can't memorize like that. They need to understand the why. So we want to make sure that we're encouraging that. Um, Sometimes we use prompts that make that flawed thinking visible, like, oh, this is a particular problem. It is done incorrectly. Where did this break down? Where is the problem with this? We also want to make sure that we're targeting the most important concept or skill from a lesson. We know that sometimes we have these lessons, specifically if you're programming or covering like it feels sometimes like 10 different topics in one day. We need to make sure we really hone in on what's the important part of this particular lesson and really kind of drive that home. Asking students to reflect on their learning process or confidence is huge, especially in middle school. Getting students to talk about what do I feel like I understand? Where do I feel like I can go with this? It makes them feel, especially for your lower students, that they are getting it, they are making progress. So we want to make sure they're able to reflect, and we want to make sure that any sort of formative assessments are really quick, really focused, and just aim for quality over quantity. An exit ticket with one question on it, not 10. So, yeah, basically, just to kind of summarize here, as we understand standards, this is a road. It's not straight. It's going to curve left and right, and we're going to, really sort of ebb and flow with exactly where we are with students' understanding of standards. But the more we know what we need to teach and sort of where we're headed with things, and the more dialed in we are with our standards, the less misconceptions you'll have, and students will have that true mathematical reasoning and understanding to be able to bring them into the higher levels of mathematics.
I don't see any questions, so we are going to quickly wrap up since it is 4:15. We wanted to include a list of links here that can help you understand standards in even more depth. Sometimes, the misconception of a standard can be um, appeared when you sort of read a different kind of question and you're like, oh, I never interpreted it that way. That makes a lot of sense. So seeing examples, this Lexile Quantile Hub is free for all New Hampshire educators. The Robert Kaplinski Depth of Knowledge matrices we also recommend as well. If you are someone who also teaches ELA, we have some ELA webinars coming up for commonly misunderstood standards coming up in the first 2 weeks of December. And lastly, again, you will have that survey pop up. If you could please give us some feedback, we love to read it and improve in any way that we can. And lastly, our emails are listed here. So if you have any questions, about what you heard today or in general, or you're looking for something specific, please reach out to us. We'd love to hear from you. And we wish you a great couple of weeks before your holiday break coming up.